Hey, Mr. K here again. We're going to talk about cooling systems today. All right. So we're going to talk about why we need a cooling system in an engine or a car, what the path is of the coolant, where does it actually go, types of coolant, radiators and thermostats, fan types, and purpose of a radiator cap, what it does. All right, so why do we need a cooling system? Go ahead and pause my video and watch this one at this time. Okay, you should have just watched that video. Let's move on. So coolant has different flow paths in different engines, vehicles, depending on what it is. But this is kind of your run-of-the-mill typical basic flow path. So let's say you dump coolant into the radiator, fill it up. When you fire the engine up, it pulls it out from the bottom of the radiator into the water pump. Excuse me. The water pump pushes it through the engine, around cylinders, through the cylinder head, cools it off, essentially pushes cool liquid through there. Then all this heat from combustion and friction heats up that liquid, sends it up to the thermostat. Once the thermostat gets hot enough, it opens the valve because it wants the engine to warm up. So the thermostat stays closed for a while. So engine warms up quickly, thermostat opens, sends that back out to the radiator, and then incoming air from in front of the car cools it off. The fan helps pull that air through the radiator, and then you send cool antifreeze right back through the engine again. The process just keeps repeating. Okay, here's a good video on that. Go ahead and watch this video at this time. All right, moving on. So different types of coolant. What I really just want you to get out of this slide is not every car takes the same type of antifreeze, the same coolant. So it used to be back in the old days, at least for American cars, you could just go and buy green coolant from Walmart. It was like $7.50 or $8 a gallon. You can mix that 50-50 to make 2 gallons, and that covered everything on your property, unless you had, a Mercedes or Volvo or something like that. But generally speaking, that about covered it. Notice it goes right up to about 96, and then at 96, GM switches and some things start getting crazy. But 96 and older, as long as you've got American cars, you pretty much just can use the green. So then companies discovered that, well, there's a lot of theories out there, and I'm not a coolant engineer, but you'll read that companies discovered that there was coolant could be tuned to whatever their engine type was, radiator type, that type of thing, depends on if the engine was an aluminum block or a cast iron block, different types of seals that are used in the cooling system and water pumps and things like that. And then the manufacturers started picking their own coolant formulations and saying that's only what will work in their vehicles. So that's where this chart comes in, and the craziness kind of began. All right, let's talk about radiators. This is a typical radiator. I used to say for an old car, but I believe it's Toyota on their newer cars still use something similar to this. But generally speaking, probably almost every car older than about 1990 is going to have a downflow radiator or vertical flow radiator. So the coolant comes in from the water pump at the top, fills this kind of tank at the top of the radiator, and then it just falls down through these tiny little cavities or fins down in the radiator and gets to the bottom, goes back into the engine, process repeats. Okay, downflow radiator. There's another way of looking at it. The heat, it's hot at the top, cool at the bottom, or cooler at the bottom. Okay, comes in here, falls down, goes back in the engine there. All right, cross flow radiator. This is going to be your typical newer car radiator, 90 and newer, roughly. This is what you're going to be looking at. I might even say 80 and newer. Probably shouldn't say 90 and newer. Anyway, cross flow radiator, same idea, except radiator antifreeze comes in one side, or coolant goes across to the other side. Okay, again, cross flow radiator. Another example of a cross flow, antifreeze Notice antifreeze tank or kind of vault of antifreeze plastic over here. There's your radiator, real wide, real long there. It pushes that across there. Excuse me. There's the outlet from the water pump. So it actually pushes it into here, fills that plastic up on that side, and then pushes it through this aluminum over to here, and then goes back in the engine. Cross flow. Okay, thermostat. Let's talk about the thermostat. We touched on it earlier, but the thermostat is what keeps the engine at a certain temperature. It helps it warm up fast. Once it warms up, it holds it at that temperature. Okay. You can buy, in the old days, you could buy them at different temperatures. You can't, that's getting more rare now. But again, 1990 and older, about maybe even 2000 and older, you could go to Napa and you could say, I want a 160 Fahrenheit thermostat, or I want a 195, or I want a 215, depending on what kind of climate you lived in or what you do with your vehicle. It could be for a variety of reasons, but you can buy different temperatures of thermostats, which we're not going to get into the reasons why you do that right now, but just know that it's something that can be done on some vehicles. And we talked about it naturally opens and closes as the temperature, excuse me, temperature changes. This doesn't require any outside power. Oh, gosh, dang it. This doesn't require any outside power. So this type of thermostat, it's just, there are different designs, but there's a spring essentially that as it cools off or heats up, depending on how it's set up, that spring gets weaker, and then another force overcomes that and opens it or closes it. So no power needed. Newer cars, yes, they have electronic thermostats sometimes, but on probably I'd say 90% of the vehicles on the road today, they don't have electronic. There's no power needed. And they're pretty reliable. They work for probably 150,000 miles at a time. All right, just another diagram of thermostats there. Thermostat closed, coolant flow, water pumps shoving it in here saying, let me through, let me through. Thermostat says no. So water pump says, okay, fine. Then I'm going to bypass and just circulate back through the engine. We're just going to keep circulating coolant until we're ready to go to the radiator. Thermostat finally says, okay, I'm ready. You can go to the radiator now. It blocks the bypass port, and then the water pump pumps it through the thermostat and right out here to the radiator. Okay, so it cools the engine off. I always like to ask, why don't we just run without a thermostat then? Wouldn't it be smarter to just rip that thing out of there and just have full flow to the radiator so we can just keep our engine as cool as possible? The answer is no, because you don't want an engine that runs as cool as possible. You want an engine that runs at the correct temperature. If you pull, I've done this, if you pull a radiator out, or sorry, pull a thermostat out and just run the vehicle, your engine's probably going to run at about depending on the weather, between 120 and 140 F. That is, you're not going to get very good gas mileage. Gasoline does not atomize very easily in an engine that's that cold. So that's one, you're going to lose horsepower, you're going to lose gas mileage. You're going to cause excessive wear on the engine, which is kind of another story for another day, but not good, not something you want. All right, let's move on to cooling fans. We talked about cooling fans a little bit. There are different kinds of cooling fans. Notice this one bolts directly to the water pump and it's driven by the belt. So that means that's a direct drive. And anytime the engine spins, that fan is spinning. As fast as that water pump spins is as fast as that fan spins, all the time, every time. Very reliable method of having a cooling fan. Probably my favorite. They're just idiot proof, I guess you'd say. They always work. But they're a little bit hard on the water pump bearings because they're always dragging. They're always pushing air, so it can be a little bit hard on the water pump bearings, and they waste gas mileage and horsepower. So in probably about the mid 80s, the manufacturers figured out they could put a clutch on that fan so they can shut it off when you don't need it. So in the middle of winter, when it's 0 degrees out, 10 degrees out, you probably don't need a cooling fan. Your engine's probably struggling just to warm up. So the fan clutch will, if it doesn't sense real hot air coming from the radiator, it will essentially let this fan freewheel. Now it doesn't completely freewheel. It runs at, I have to refresh my brain, but I believe it runs at about 10% of the speed of the engine when it's not needed. So it does still drag the engine down a tiny bit, but it saves a ton of gas mileage and gives you more power. Okay. And of course, when it becomes too hot, when this senses the radiator pushing hot air through, then it locks it back up again so that it spins with the motor. So if you thought the clutched fan was the best of all worlds, how about electric fans? Okay, electric fans are pretty cool. They'll be off all the time, don't spin at all until a thermal switch or the engine coolant temp sensor senses high engine heat, and then they'll kick on. So the great thing about these is you have complete control over them via the ECU or the thermal switch. So you're not wasting any energy at all in the middle of winter. These things don't have to spin at all. No drag on the battery, no drag on the engine. And when you need them, they kick on. Pretty cool, but more things to break, not as reliable. Again, the clutches on these fans go out, your engine overheats, it's one more thing to break, okay? Not as reliable as your old school direct drive fan, but we make a lot of sacrifices for fuel mileage and horsepower, and these would be examples of those. Okay, so we just talked about that. Electric fans get you more power to the wheels. They're easier on your water pump bearings. Okay, better mile per gallon. Okay, we talked about all those things. So the radiator cap. People don't realize how important this is. They think it just keeps coolant in the radiator, but it doesn't. Okay, it builds pressure in the system. So this controls system pressure because it's got a spring, and it's got, I probably should have had a better photo here. It's got a spring inside of the cap, and it's got a rubber seal there. It seals down here. And as the system heats up, pressure expands. It will build pressure inside of the system until that radiator cap says it's okay to vent. So it brings us to our next point. Why wouldn't we just vent the system? Okay, we don't just vent the coolant system, because if we did that, then the pressure would be too low and it would cavitate. You'd have bubbles inside the coolant. You get erosion. So radiator caps often tell you the pressure right on the cap. So all you got to do is look at them, and you can see at what pressure that cap will open and vent the system. If the cap goes bad and vents, the coolant will boil. Okay, you do not want coolant to boil. If coolant boils, a pump can't pump it. Water pump's made to pump liquid, not air. So if you get boiling coolant, will not cool the engine, will overheat. That is an ASE test question. And then go ahead and watch this video, and that will be it. Have a good day. That's your reminder to not open that cap when the cooling system is hot. Very dangerous.